All right, Matt, do you want to read off that first problem?
Number 1. John starts from rest and begins to accelerate at 10 meters per second squared for 8 seconds in his car. How fast is he going at the end of the 8 seconds?
Okay, so as you were reading that, I pulled out our four variables. I have that the initial velocity is 0 meters per second because you said that John started from rest. You also said the acceleration is 10 meters per second squared, the time is 8 seconds, and we are looking for our final velocity. So I'm going to use our equation. Final velocity equals initial velocity plus acceleration times time, and I'm going to plug in our knowns. We have final velocity equals 0 meters per second plus 10 meters per second squared times 8 seconds. 10 times 8 is 80. So we have our final answer. Final velocity equals 80 meters per second. Boom, easy. Let's go on to number 2.
Number 2. Luna accelerates at a constant rate of 2 meters per second squared until after 3 seconds she catches a ball at a velocity of 12 meters per second. What is her initial velocity at time equals 0 seconds?
Okay, so you stated that the constant acceleration is 2 meters per second squared. The time is 3 seconds. Her final velocity is 12 meters per second, and we're trying to find the initial velocity. I'm going to set up my equation. V final equals V initial plus AT, and we want to solve for the final velocity. So we have that final velocity equals V final minus AT. So I'm going to do the algebra to solve for initial velocity. We subtract AT from both sides, and there we have the initial velocity is equal to the final velocity minus acceleration times time. Let's plug in our variables. So we have the final velocity is 12 meters per second minus 2 meters per second squared times 3. Simplify that. We have 12, and 2 times 3 is 6, so we have 12 minus 6, which gives us our initial velocity of 6 meters per second. We always want to include the variable meters per second whenever it's a velocity we're solving for. All right, let's keep going.
Number 3. An F1 dragster overtakes the leading car by accelerating from 32 meters per second to 45 meters per second in 17 seconds. What is the acceleration of this car in this time period?
Okay, that one almost threw me off. I began writing down the acceleration because you said it, but it didn't actually give us the acceleration. That's what we're going to be solving for. However, we were given that the initial velocity is 32 meters per second, the final velocity is 45 meters per second, and the time is 17 seconds. Let's go ahead and write our first kinematic equation. V final equals V initial plus AT. Here we want to be solving for the acceleration, so I'm going to be doing the necessary algebra. First, I'm going to subtract V initial from both sides. And then, to isolate the acceleration, I'm going to divide both sides by time. Here we have our equation. Now I'm going to plug in our variables. We have the acceleration equals V final minus V initial over time. 45 minus 32 over 17. Let's simplify that. 45 minus 32 is 13, and it's still over 17. Now, we could spend some time and do some long division here, but I'm just going to plug it into my calculator. 13 over 17, and I'm going to get it in decimal form that the acceleration is equal to 0.76 meters per second squared. It's meters per second squared because it's the acceleration, and those are always the units for acceleration. It's distance over time squared, and I'm using two significant figures because that's what we were given in our initial problem. Okay, let's do the next one.
Number 4. How long does it take a bus to decelerate from 22 meters per second to a stop if the brakes allow a constant deceleration of 4 meters per second squared.
Okay, this is a trickier one. We have that the initial velocity is 22 meters per second. The final velocity is 0 meters per second because we want to go from moving to a full stop. It also says that our deceleration is 4 meters per second squared. Because it's decelerating, it's slowing down, and therefore the acceleration is going to be negative. Finally, it's asking for time. Let's set up our equation to solve for time. We always start with v final equals v initial plus at. We subtract v initial from both sides. And now we want to divide both sides by acceleration to isolate time. Let's plug in our variables. We have time is equal to v final, which is 0, minus v initial, which is 22, over our deceleration or acceleration, which in this case is negative 4. So we end up with negative 22 over negative 4. Now a negative divided by a negative is always a positive. And we always want to make sure that our time is positive because you can't go back in time. So 22 over 4 is 5.5 seconds.